Hi, everybody. My name's Geoff Gerhardt. I'm CTO and co-founder for Scitara. I'm going to talk a little bit today about Scitara's product DLX and how we can help bring sort of your lab into the context of the rest of your IT infrastructure that is cloud-based. I'm joined by Jeff Mazzeo, Jeff with a J, I'm Jeff with a G, and he's Chief Marketing Officer, and he's going to talk a little bit after I present. So I'm going to start my screen share now. Okay. So as I mentioned, what I'm going to talk today about is extending a composable IT architecture into the lab. So what do we mean when we mean a composable architecture? That's sort of a generic term now for a system that's composable is when applications can be created by configuring modules rather than sort of hard coding something. It's really the standard now in development, DevOps, and IT enterprises. The term composable enterprise is uncoined by Gartner, and it really talks about an IT enterprise that utilizes a base of modern cloud-based technologies for specific purpose functions like email or file storage. And then uses an integration platform that allows these these technologies to be connected with little or no coding experience into applications that can meet business needs. So that's what I mean when we talk about composable enterprise. And unfortunately, the lab right now doesn't really participate in modern composable enterprises. So if we think about building that composable enterprise, as I mentioned, usually you'll pick your sort of business-specific technologies like email, Slack for communications, Office 365, your Box, Snowflake, AWS for file storage and data lakes. You might get some other cloud-based technologies for data visualization or data manipulation. And then quite often you'll pick some sort of an identity provider that can really stitch all of these together. And rather than have different authentication platforms for each of these, once you have one authentication provider, now they all authenticate and can exchange information between each other. Most of these are all that have APIs that allow them to interact. Now that you've got them all authenticating and they have APIs, now you can use things like iPasses. Now, this is another term that's become popular, integration platform as a service. It's really the technologies that can stitch a lot of these cloud-based services together. So something like Microsoft's Power Automate, that's a relatively simple iPass that allows you to connect things like when you receive an email, start something. When you see this one, you can start an approval for new documents by notifying via Teams. These are things that allow users without much training to go in and create these automations in a visual format. A technology like MuleSoft is more of an enterprise scale iPaaS where you can create corporate processes and that, again, by stitching together all of these individual services. So now the problem is that when you get into the lab space, quite often you'll have cloud-based ELNs or LIMS system that aren't really well represented by things like MuleSoft or Power Automate. They're more bespoke web services that are more. A lot of the current iPasses focus on standard business applications. The other thing is all of your lab IT architecture exists quite often on-prem or in a protected network environment that it is difficult to make them cloud-based. And so as a result, your lab really isn't able to participate in this composable ecosystem that you've created. This is where Scitara can play a role. I'm going to talk about the technology we have to connect a lot of the on-prem, even if it's in a protected network, and make them cloud accessible. And then once they are, then you can connect those into not only your cloud-based ELN or LIMS system, but any other cloud-based technology that we provide connectivity for. So this is a typical deployment topology for a customer who's deployed Scitara DLX. In the middle, you see our platform. It's typically an AWS hosted microservice environment that we can either do it as a dedicated single tenant or as a as a multi-tenant deployment. Once that's deployed, we can connect into typical cloud-based applications like the general business applications, Box, Snowflake, Office 365. But more specifically, we have connectivity into a lot of the lab-based cloud assets, things like Snowflake, or rather ELNs, like Signals Notebook or IDS Polar or Benchling, and cloud-based LIMS systems like Labware LIMS or LabVantage, as well as a lot of customers have cloud-based resources, S3 buckets, data lakes that they need to connect into, and we have connectivity strategies for those. But more importantly, we have a lot of technology to connect into the on-prem systems. Simple devices like balances, particle counters, pH meters. We have either an IoT device that can connect into those, or you can use this multiplexer that allows you to connect those into the and aggregate them into one connection up to the DLX cloud. We also can connect into the more sophisticated instruments, things like HPLC systems, Empower, Chameleon. We have agents that can install on those Windows PCs that run those, or the cloud applications that run them, and then also connect that up to the DLX. So once all of these simple devices, applications, and cloud applications are installed, they're all essentially peers on the same network. So that's, when I think about DLX, this is essentially how I often explain it. On the bottom half, really we're taking what is typically a heterogeneous, non-cloud, very poorly described interfaces that don't have a lot of documentation. On the top of DLX, what DLX exposes is a cloud-based, very consistent, schema-described, event-driven interfaces. So all of these are now normalized, and so it's much more straightforward then to create connectivity between them. The first platform, the first tool we built on top of this is what we call orchestrations. Orchestrations are automation. They're a linear series of steps. It starts with some sort of a trigger. That trigger could be a manual trigger by a QR code by a user, or when samples are ready on a chromatography system, or a file is dropped into a directory. All these are types of events that could trigger an orchestration. And then once it's been triggered, you can configure a number of steps to exchange data between different connectors. So I'll just use a simple example of how you might use DLX in a situation. This is a typical bioprocess development lab where you have a bioreactor that you would start running, and then every few hours you might take a sample off that bioreactor and take it to any number of analytical instruments to be able to analyze those. And really, you'd like to run that whole process from an ELN, or even from be able to send that data to a spreadsheet. So what you can do with DLX then is get the connectivity for all of these instruments and bioreactors that you want to be able to participate in this, and then begin to write these applications or orchestrations that will allow you to move all this data around and respond to all the events in here. So as an example, we have OPC connectivity that allows you to connect to a bioreactor. So you'd probably write an orchestration that would be a timed one. Every 10, 20 minutes would take a snapshot of that bioreactor and send it up to the ELN or the spreadsheet. Also, the lab technician would probably want to be able to register bioreactor samples that were taken. You can start an orchestration by triggering it by a QR code scanned on your mobile device or iPad. It'll walk you through the steps of registering that sample and push it to an ELN. And then once you're taking these samples to the analytical instruments, orchestrations can be constructed that can set up these instruments with the sample, and then push the data once the sample's been completed into your ELN or online spreadsheet. This is what our orchestration editor looks like. It's a user-friendly interface where you can just start by defining what kind of how this orchestration will be triggered. In this particular one, it's a user-triggered one, which means it can be done manually or by a QR code. And then you can begin to build steps. And this one, the first step is a user input step. So after this is triggered, you'll see a form that the user will have to put some information in. It'll create, in this one, a new spreadsheet, create a batch record, and send a notification indicating that the Scitara actor run has been set up. In this orchestration editor, we provide really easy ways to reference data from previous steps. You can simply click on a step and grab the data from that and use that in the options for another step. Oh, so those are orchestrations, and right now that's what most of our customers use to create automations. They're all event-driven. An event can start from an ELN or a LIMS system to push data into a setup, chromatography system, or they could come from an event from that chromatography system when data is ready to push it back into the LIMS or ELN or into an online spreadsheet. Something that we're working on and we're hoping to release shortly is another technology we built on top of this platform called Workspaces. Now, Workspaces, unlike the orchestrations that it's a linear series of steps, it's more like a dashboard that you can create. So this is the editor for Workspaces, where you can see that you can select visual elements like an input box, a graph, a number display, and arrange them on your dashboard. And then once you've got those visual elements, you can connect them to data that's produced from the DLX platform. So this allows you to create these dashboards that are live and you can view from anywhere. Once you've created a workspace like that, you're given a unique URL that you can use to execute this workspace. So in this one, you could render this on an iPad or your phone. So if you're home and you wanted to see how your bioreactor was doing, you can create a workspace that would show this live and be updating, and you can see it from wherever you could render this URL. So the last thing that I want to talk about is the next platform we're building onto this is what we're calling DLX agents. As I said, right with the this platform really provides a very normalized interface now that you can build lots of tools on top of. What we're most excited about is beginning to allow AI onto this. So a lot of the AI tools require some sort of a normalized interface that they can execute on. So we anticipate it's going to be relatively straightforward to allow our users to talk to their system with natural language. So you might create an agent that says, monitor bioreactor XYZ, provide me with a summary at the end of every day, and if the cell viability drops below 80%, notify me immediately. In doing this, we're building tools that use large language models to interpret that agent, what they want to do, and then we're creating tools that large language model can then use to execute and get the data it needs from your DLX connected devices and applications. So we're really excited about this one. This is one that we think is going to really take advantage of a lot of the connectivity we have, as well as a lot of the technology that's emerging now with AI. So just to summarize, as I mentioned, DLX is an iPaaS designed for the laboratory. We have a connectivity that connects into a lot of the lab assets, whether they're on-prem or cloud-based. On the on-prem, we've got a very secure, robust way to connect these with redundancy built in. So once you've got this connectivity, now you can create these applications using orchestrations or Workspace in low and no code tools. We do allow you to insert code in here if you want to access the data if you want, but really we designed it so you don't have to be a developer to create these automations. And then we do think this is a normalized modern connectivity layer that we're really going to be able to leverage with a lot of the emerging AI tools. So I'll stop there. Geoff, do you want to take some questions now, or do you want to move around to your presentation?
Yeah, why don't I share the few slides that I have, and then we'll do the Q&A after that.
Sure.
So thanks, Geoff, for all that, and hello everybody again. My name's Jeff Mazzeo, Jeff with a J, and I'm the Chief Marketing Officer here at Scitara. So what I wanted to do is Jeff's kind of taken you through the technology aspects of our solution and how it enables a composable architecture. What I wanted to share with you is just 3 slides to talk a little bit about what are some of the reasons why our customers are adopting this technology, and what are the types of impacts that they're seeing. So I'm going to go ahead and just share. Like I said, I only have 3 slides to share to kind of set that up, and then we'll move to the Q&A. So most of our dealings thus far, which is kind of interesting in many ways, has been with quality control laboratories at pharmaceutical accounts. We are starting to deal more with R&D labs, and I'll talk about that in the last slide. But a lot of our initial engagements have been with QC labs, and we think there's a lot of reasons for that. One is that in QC, it's generally a lot easier to justify investments in digital technology because you can very easily measure the ROI. And the other is that there's a drive to try to improve productivity in manufacturing and QC in the industry as well. So when we talk to pharmaceutical QC teams, we usually talk to 2 different sets of personas. One is what we refer to as the business owners or the leaders of the lab, right? The leaders of the QC team, managers of the QC lab, et cetera. The other team is usually within the IT organization that is meant to support the lab leadership from a technology standpoint. Many of the companies that we deal with as well have set up what they call these digital science teams, which are oftentimes a hybrid of IT and lab, to try to set up a roadmap to determine how they're gonna digitally transform and realize the benefits of digitalization in their labs. So I wanted to just share at a high level, what are some of the drivers that we hear about why you would want to adopt a composable architecture in the lab, and why our solution can achieve and meet those challenges. So for business owners, probably the biggest thing that we hear pretty consistently is the need to improve data integrity. And in fact, many of the customers that we've dealt with thus far, they usually will have internal initiatives around eliminating manual transcriptions. It's kind of interesting in today's digital era that there's still a lot of manual transcriptions of sample sets into instruments and instrument results into LIMS that's going on. And obviously that there's a lot of issues with that, not the least of which is data integrity challenges. So by eliminating those, you can eliminate errors, and you can also save a significant amount of money. So that's probably the number 1 driver, I would say. Somewhat related to that, we also hear a lot about the need in QC labs to do more with less. How do we become more productive? How do we reduce our costs while at the same time improving our compliance? And, the types of technology that we've talked about today can certainly allow you to do that. Another big driver, especially with the move towards new modalities like cell and gene therapy products, is the need to be more agile in the lab. And what we mean by that is that because of these new modalities, they typically require different analytical technology for doing the QC testing. And so QC labs need to be able to adopt that new technology very rapidly, integrate it into their workflows without any delay in cost. And one of the benefits of a platform-based approach to integrating lab assets, like Geoff just talked about, is that it's very easy to do that, because once you connect something to the platform, it can begin to now automatically exchange data with other assets in the laboratory through the platform. So that increased agility is a very important driver. And I should point out that contrasts with the way these things are normally integrated in the laboratory is with what we call point-to-point integrations, where you build, point-to-point integrations between a LIMS and an instrument, for example. That they have been around for a long time. You can certainly do that, but they really have a lot of negative impact, especially with regard to agility. Because if you want to put something new in, you've now got to build all these new custom point-to-point integrations, which are costly and add a significant amount of delay. And then the final driver that we often hear from the business owners is the need to increase revenue and reduce risk by reducing batch release time. How can we get batches out faster? How do we cut our release time down while at the same time improving data integrity? And that's certainly enabled as well. When we speak to the folks in the IT world that supports QC or the digital science team, similar themes. One of the things that many of these laboratories have done recently is they've made investments in either new or upgraded versions of their LIMS or LES, laboratory execution system. And oftentimes, those can be very long deployments, especially as it relates to instrument integration, which is key, right? To be able to automatically exchange data between your instrument portfolio and those solutions. So maximizing time to impact or minimizing time to impact, maximizing ROI is a big driver that we can help with. Same goal with agility, and Geoff talked about composable architecture. I mentioned point-to-point integrations, and again, they are been in existence for a long time, but they're extremely expensive to maintain for the reasons that I talked about before. If you want to make a change, then you've got to make changes to those point-to-point integrations. If there's a new version of software that a vendor introduces and you want to upgrade to that, now you've got to redo those integrations, et cetera. And then finally, the last driver I'll mention for the IT teams is related to how can they also reduce their costs. So simplifying their tech stack, and also especially for multinational corporations, how do we standardize across our sites in terms of how we're doing things? And certainly an iPaaS for the lab in the composable architecture really is an enabler of that. So I have two examples to share that start to quantify the benefits of adopting this. The first one is with a biologic. It's actually a vaccine manufacturer. And it's very specifically focused on a test that's used to QC these vaccines called flow cytometry. So the workflow here for this particular test is laboratory execution system requests some flow cytometry analysis as part of a batch release. The flow cytometer has to perform the analysis and generate the results. The results are then in the LIMS to ensure that it meets specification and can be released. The challenge for this particular lab was the fact that all of these steps, the movement from the LES sample list into the software for the flow cytometer, and then the results from the flow cytometer into the LIMS, were completely manual. So all manual transcriptions, between those three assets: LES to flow cytometer to LIMS. And in fact, what they told us is that at one of their sites that just has one of these labs where they tested it, one of these instruments, where they tested it, they were typically having to do 500 total manual transcriptions per week for that one instrument at one site, which required a total of 24 hours of analyst time to do those. So obviously what they wanted to see is, hey, can we use Scitara DLX to link up these three assets and automate this process so that we can eliminate manual transcriptions? And indeed, they were able to do that. Obviously, eliminating those manual transcriptions eliminates all potential errors associated with them. When you quantify the savings, those 24 hours of analyst time per week, and you make some assumptions about labor rate, we're talking about a relatively modest amount, $200,000 in cost savings per year. But remember, that's just for one instrument in this one site. So you could scale that across multiple sites and more than one instrument. They also were able to achieve a 20-hour reduction in test completion time. Obviously, that's not the only thing that's involved with batch release, but that does give you that shorter release time or contributes to it. The thing that's really hard to quantify and that we don't have here are the cost savings associated with error investigations. Manual transcriptions are problematic because they take time, they add cost, but the big issue is they add errors. There's always some level of error that's going to occur with a manual transcription. So if you can eliminate them, you save the time associated with error investigations. Now, if you can catch the error as part of review, maybe it's not that big of a deal. But if you don't catch it early on and it comes out, God forbid, after batch release, now you're talking about a significant investigation and significant cost. So that's again a big driver for eliminating these manual transcriptions. Finally, one of the things we also hear from QC lab leadership is that many of the technicians that they employ today are what we call digital natives. That is, they've grown up in a world where everything is digital. And so when they go into a laboratory and they're told that, hey, you've got to manually transcribe and type in, sample lists and results, they really are just appalled by that, right? It's like, that's just, they don't believe that they should be doing that in today's day and age. So by eliminating that from the lab, there's also a benefit in terms of morale of the staff, because it allows them to focus on higher value add tasks instead of having to do trivial manual transcriptions. So that's just one specific example, again, in a QC. Now in the pharmaceutical R&D space. So this is a customer that we worked with recently where they have a set of 9 instrumental tests that they run as part of the development process for some of the therapeutics that they're working on. And their current process is that they run each one of those instruments. So there's a certain time associated with the instrument runtime. But then once that data is generated, again, same issue. They've got to now manually transcribe the results into Microsoft Excel. They need to check and rework the data, assemble it in some ways, make sure that there's no errors, aggregate it, and then copy and paste it into another file folder or beyond Excel, do another set of check and rework. And then eventually they want to put it into a data lake where they can do analytics and visualization. So all those reddish color in the middle there, that's all essentially manual steps in the process. So what they wanted to see was across 9 different instrument types, could they eliminate that, and how much time could they save by doing so? So they evaluated Scitara DLX to again help automate all those steps there, which allowed them to automate the putting the data, the final results into a data lake, so that they could then provide that to users across the lab and the company, in fact, to do analytics and visualization. And what they found, again, across 9 instruments, is that they could reduce the total time, by 86%. And really, the only time that's remaining is the instrument runtime that needs to occur. So this is another example now where multiple instruments across multiple different types of tests, you can see how with this technology you're able to eliminate all those manual steps, gain significant time savings, but also serve up data that's really ready for analytics and visualization without any errors associated with the transcriptions. So I thought I would just share a couple of examples of the impact that our customers are seeing with this technology. So I'm going to go ahead and stop sharing. And Geoff, I'll start with some questions for you. One of the questions that we get asked a lot is related to what I just talked about, which is data lakes and how our solution works with data lakes. So I think the specific question is, how does DLX work with data lakes? And are there any advantages with using an approach like DLX in a composable architecture to feed data and results into a data lake? And Geoff, you're on mute, I believe.
Sorry. Yeah, this is a question we get quite often. So there's a whole number of ways to use to get data into data lakes. The one thing is that when you begin to use DLX to manage a lot of your workflows, you already have an automation pipeline running. So if you have a request for a sample analysis on limbs that goes to a chromatography system, and then when that data is ready, it gets pushed back into a LIMS. You've already created automation workflows for doing that. In any of these, you can just tack on a step, which send the data, push the data to your database, so your data lake. As far as the data lakes we support, one that is quite common is Snowflake. Our users are using. We have a Snowflake connector that allows you to push data, JSON data, or however you want to format it onto there. You can take all of the so a lot of users that are doing chromatography and have a result that comes back to fulfill a request from a LIMS system. Really, all they're really interested in for that result is a peak height or something like that. But there's a lot of other data that comes back that they want to push to that data lake. So in addition to when you get that result from the chromatography system, you may push all of that peak information data to your data lake and just take the small part that you want to go to the LIMS onto there. So that's with all instruments. Quite often what we're seeing is that to complete a workflow, you can do that with the data necessary, but rather than throw away all that data you got back from the instrument, you can add a step onto an orchestration that pushes it off to a data lake, whether that's something like Snowflake We have also, a lot of our ones have sort of data lakes that they've created themselves that have API endpoints. We have a generic web service connector that you can use to push the data and authenticate to whatever data lake that you constructed as well.
Excellent. Next question, Geoff, relates to operating our technology in a QC lab or a regulated environment, and it relates to like what types of controls are in place for like security of the data, data integrity, et cetera. Are there any features in the product that ensure that our customers can be confident in that?
Yeah, like you mentioned, Geoff, really where we found ourselves, most of the customers, early customers, were large pharma in QC and manufacturing. When we started Scitara, we did want to start it with a quality management in place and the product designed from the ground up to be 21 CFR compliant with all of those sort of regulatory controls built into it. Sometimes it's easier to get a product out that goes into the research or development market that doesn't have a lot of those, but it's very difficult to add those into the product after. And so right from the start, we built the company with a quality management place that we've been audited several times by some of our large pharma customers. And then the product itself has all of the change management controls built into it, audit trails. So anytime, if you do have the audit turned on, you're asked reasons for change for every time you change an orchestration. You can see an entire audit trail of anything that happened, as well as an event trail. So when an orchestration happens, you're able to go back and see every event that happened during that orchestration. That's great for diagnostic purposes, but it's also good, from a regulatory, be able to go back and verify that everything that you intended to happen actually happened. So as I say, it's really built from the ground up to be a regulated system. For if you want to deploy it in a non-regulated environment, there's just that's something that you can just turn off and have it without the regulatory controls on. But it is built into the software.
Great, Geoff, and maybe kind of related to that, another question in a regulated environment is the validation burden, and does Scitara do anything to help with the validation of the system in the lab?
Yeah, so that's one that we appreciate that need to be able to deploy it in a development to be able to develop a lot of your automations and then move that to a production. So we both have a services organization that can help with that. But when we have a customer that's in a regulated environment, you deploy into multiple different tenants that represent development and production and staging, and allow you to move these workflows in between those so you can deploy in a regulated space. We also, if you are in a regulated space and you want to have better control over our release schedule when we upgrade you, so that you can manage your migration to those, you can have a privately hosted single tenant where you have much more control over when the next release will be adopted, and you can revalidate. So it's both. We offer a number of things in the product to help move those workflows into the release date, as well as a services organization that can help with that validation.
Excellent. Maybe a slightly different question. One of the things that's come in is around our connectivity strategy. Like, how do we connect to all the different things, right? So maybe you can just talk a little bit about the universal connectors, branded connectors, et cetera.
Yeah. Let me maybe see if I can find it. As I had a slide from another presentation that. Okay. If I can find it here, that talks about that connectivity. That's one things that we get asked a lot of in that connectivity strategy, because it's kind of like trying to boil the ocean to have connectors for every type of technology in the lab. The way that we've approached this is we do have a number of what we call branded connectors. These are ones for something like benchling or labware limbs. They really require a bespoke connector that's written specifically for those ones. We also have a number of base connectors. These ones, something like an RS-232, if you have a Mettler-Toledo balance or a Sartorius balance, you can use that base connector and configure it to work within those things like file service or a generic web service connector that you want to configure to work with your data lake. We have those base connectors. You can then take one of those base connectors and configure it to work with that Sartorius balance that you have, and then publish that as a new connector. So you don't have to configure it every time. You can publish that as a new connector. And so you can create as many connectors as you like, taking these base connectors and configure them for you. So it's your specific application. This is what we want to get to, is a connected community, so our users can share these configured connectors with the community. That's how we'll boil this ocean, is really having both these base connectors that talk to a lot of different instrument technologies, and allow our users to create that community of connectors that we have. But as I say, we have a whole number of partners that are giving us access to their APIs, and that for those that really do need a specialized connector, we put a brand connector around.
Yeah, great. Yeah, it makes sense. Maybe the one thing I would add to that too, Geoff, is the fact that we try to position ourselves as being vendor neutral, right? We need to connect to everybody's equipment, applications, et cetera, because the one thing that you find in the laboratory environment is that it's extremely diverse, right? Everybody has their preferences about which instrument or software they like to use. So our strategy is we're vendor neutral, and therefore we need to connect to everything. And as Geoff mentioned, our partnerships are a really key aspect of that. Another question, Geoff, that we get quite frequently is deployment speed and deployment time. And I wonder if you could speak to how long it takes to maybe get Scitara DLX set up in somebody's laboratory.
Yeah, well, that's the actual time to deploy. Usually, the way it starts is we'll understand the connectivity that you need, the different connectors. We have a services organization that will go in and work with you, and usually our customers will start by defining one or two workflows that they want to automate, whether it's an HPLC system with a balance or a bioreactor. We'll make sure that we have the connectors for those and help you get them configured. The actual deployment of DLX takes really minutes to once we've created a tenant and deployed it. It's just helping the customer understand how to use the platform and then get their connectors deployed and connected. And then we start the process of helping you build the orchestrations and automations. Really, when we deploy it, the end game isn't to have a long services relationship with the customer. Really, we want to get the customer trained on how to deploy their own connectors and how to write orchestrations, where we've made it so it's relatively straightforward to do and understand. And so the engagement is usually first, we help with getting the first few automations done and getting the system deployed, and then really hand over the keys to the customer to be able to complete that and deploy that across the rest of the lab.
Yeah, and maybe just the one thing I'd add to that too, Geoff, to your point about enabling our customers. We just have launched this year something that we call Scitara Academy, which is an online training module to learn about the basics of Scitara DLX, but then advanced features like setting up orchestrations and automations, et cetera. So I think that completes the questions that we've had. I want to thank everybody for listening to us today. And Geoff, thank you for your presentation. And I think at this point, we will sign off. So thank you, everybody.
Thanks, everybody.